Hello world, my name is Victor Engelmann. Welcome back to this series on professional network design using Linux. Today I want to talk about PXE, the pre-execution environment, or PXE for short. That's a system that allows you to boot a machine, like this laptop here, without even having anything installed on the hard drive. So you don't need a local bootloader or operating system. You can just pull that over the network. It's also called network booting. And that's what I'm going to show you today. In theory, you could actually use this to load your full operating system like that. So you could load like something like, I don't know, just a little Linux kernel with an boot script that mounts some network shares and mounts them to home and bin and lib and so on. So you could, in theory, put your entire operating system into the network like that, and then even not even have a hard drive in your local machine. You could just boot really completely over the network, but that would be pretty slow, so that's not something you would do in reality. In reality, what you do is you only boot an operating system installer like that, okay? And then you don't have to put the installer on an USB stick or burn it on a disk or whatever. So and I mean, if you have a large company, you don't want to have something like 50 different USB sticks with maybe different versions of the installer, and people therefore using different installers for installing machines, right? So that's what you typically use PXE for. And let's dive right in. How can we use that? It's relatively simple, honestly, but I actually wanted to make this video about a year ago already, but I just couldn't get this running. Okay, so the problem back then, I think, was that I was running I had one big network. You know, right now I have multiple little VLANs. I've showed you how to do that. And back then everything was in one LAN, and the DHCP server of my Fritzbox was running and giving out IP addresses, and this PXE booting uses DHCP, and supposedly you can just run multiple DHCP servers and have this PXE on one of them and your normal IP assignment on a different one, and it supposedly works, but I absolutely couldn't get this to work. So if you are doing this, either turn off your DHCP server and use an ISC DHCP, for example, or DNS mask DHCP, whatever. So just don't use such a stock DHCP server that doesn't support it, okay? Having multiple DHCP servers on the same network, they won't play well together, usually. So again, now everything is in small VLANs, and the LAN that I'm doing this in, the VLAN I'm doing this in now does not have a Fritzbox DHCP, okay, so that's not going to interfere. Okay, so how does PXE work? When you boot your machine, the hardware has to support it, and if you boot the machine, you can tell your BIOS to boot over the network using PXE, and what your machine will then do is it will send an DHCP request outside of an operating system, right? You can do that on a blank machine even without a hard drive, so nothing has to be installed for this. The hardware, it's like in the BIOS hard-coded into the BIOS that it can do a DHCP request without an operating system running under it. Okay, so it does a DHCP request, gets an IP address, and that DHCP request can also tell you to, it can also give you a TFTP server, that stands for Trivial File Transfer Protocol, and then tell you to use a certain file name to boot from. Okay, so these are two informations that can be sent with the DHCP answer, and yeah, the machine can then contact that TFTP server, pull that file, and use that for booting. Okay, so let's do this. So I've prepared a Raspberry Pi as a TFTP server. I've given it the hostname TFTP server, very creative. And it has the IP address 10.190.55 because I'm doing this in VLAN 90. You know, that's my IP addressing scheme, 10.1, then the VLAN number, and then something controlled with a DHCP server. Now my laptop is also in VLAN 90, 10.190.54 through a network cable. So it's connected through cable. I think that's important because I don't think that the BIOS would support this network stuff over Wi-Fi, so it needs to be wired. Okay. And yeah, I've prepared an SSH server on the Raspberry, so sorry. Okay, now I'm logged onto the Raspberry Pi, and yeah, we now have to put here the file for the machine to boot from. Where do we get that? I will use Debian for that. Here on debian.org/distrib/netinst. You have this installing Debian via the internet, and over here we have an entry for network boot. Right over here you have images for CDs and USB sticks, but over here we have an image for network booting. This is an AMD 64 architecture, so I will go there. Netboot, and here this netboot.targz, that's the file we need. I will copy the link address, and over here on the TFTP server I will now download the file. I just had a little problem downloading this file before, because the Raspberry wasn't configured to take the NTP server from the DHCP, and yeah, since I've blocked NTP in my firewall, yeah, the Raspberry didn't have a correct time, and that threw off the SSL in the HTTPS, and that's why the download failed. Something to keep in mind: if you block NTP, then you have to configure at least your Linux machines to take the NTP servers from the DHCP replies. Otherwise, your time configuration won't be correct, and yeah, that can throw off SSL. Okay, it's finished downloading, and yeah, now we have to make this available over the network. For this I will install TFTP daemon-HPA. Okay, and now we have to configure that. It's configured in etcdefault TFTP d-HPA. It doesn't have many options, but yeah, this TFTP username, that's actually not something for authentication of the client to the FTP server. This is a username of a Linux user on the Raspberry with whose credentials the service will be running. Okay, it's using TFTP. I think that's probably a user that's created in the installation of the server. I'm guessing that this user has access to this directory and that this directory is also created in the installation. TFTP address. Well, if the Raspberry had multiple IP addresses, then we could set the listen address, like for example, if we set this to 127.0.0.1, then it would only accept local connections, but of course that wouldn't make sense for network booting. Just use :69 to set the port to 69. That's UDP packets, by the way, UDP port 69. If you are doing something with a firewall in between, then that's then you have to open UDP port 69 to the server. Okay, and then further options, TFTP options. For this you can look into the TFTPD man page, for example on debian.org. Here you have several options that you can put there. One important setting maybe is down here, this port range. Because the way TFTP works is you send a request to download a file, but unlike in HTTP, for example, where you get the result on the same network connection that you have established, FTP and also TFTP establish a connection back to you. Okay, and this port range here specifies the source port. So you can give it a range and say, hey, I'm only allowing source ports between, I don't know, 6,900 and 6,999, just so that you can control on your firewall that you allow packets in this port range. But that's even a bit crazier than it sounds, because let me show you in the rules here. In my rules, I have created this rule here that specifies the source port. I mean, limiting source port is normally not something you do in a firewall. But when you do that, then when you create the rule, you even have to go to this advanced mode here to then be able to set the source port range. So that's really unconventional in today's networks, but it's a relatively old protocol, so yeah, that's just the way it is. Another important option here is the secure option. So when you set the secure option, then the client can send a request for a file, and then the server will look for that file relative to this TFTP directory. Okay, so if you have a file directly in here, let's say foobar.txt in here, then the client can download that by requesting foobar.txt and doesn't have to say give me /srv/tftp/foobar.txt. And I mean, yeah, the client shouldn't even know your directory structure here, so that makes total sense to use this secure option here. Okay, let's see. Let's go to this directory. Now let's move the bootloader here. Since this directory belongs to the user TFTP, I will have to use sudo. And I will change the owner to TFTP. Okay, so now TFTP is the owner of the file. Okay, for testing purposes, I will just create a file hello.txt. Okay. I will change the owner of that file also. Okay. Now let's check the status of the TFTP server. Okay, it's running. So let's try downloading this test file. So I'm installing TFTP-HPA on the laptop. Notice that here I don't have the D for the daemon because I'm installing the client and not the server. Okay. Now name of service not known. Let's see. Okay. You don't have to put the colon there. Okay, and now let's request that file. Okay. Control D to leave, and yeah, we've downloaded this hello.txt. So yeah, the TFTP server is running. That's already good. Now now we have to unpack the bootloader. Okay, we've unpacked things, and notice this PXE Linux.0 here. That's actually the file that we want to give to the client. So I'll delete hello.txt. I'm not owner of that. yeah, it's a bit stupid that I'm logged in as Pi and working on files belonging to TFTP, but whatever. Okay, now everything belongs to the user TFTP, so TFTP has access to all files, so that the FTP server is then able to serve all these files in here. Okay, I think the TFTP server is complete now. And yeah, now we have to configure the DHCP server to to tell my machine to boot that. Here on wiki.debian.org/pxe boot install, you'll find a lot of options that you can use. Here, next server, that's the server of the that's an IP address of the TFTP server. And here, file name PXE Linux.0, that's a file that I just shown you to boot from. But in ISC DHCP you can also distinguish cases, like you can give different file names for different architectures and stuff. Since I've had so much trouble in the past with this, although I'm not doing this in a network with multiple DHCP servers, I will still do it through the OpenSense configuration. Okay. Here under services, DHCP4, VLAN 90. I'm running a DHCP server that serves IP addresses 10.190.50 to 200. Giving a DNS server, a gateway, domain name, domain search list. Okay. Network booting here. So if you're looking at these options here, they very much correspond to the options that you have here, right? So for different architectures, you can set different file names. Here you can set different file names for different architectures. Okay. Next server IP, I really don't know why they named it that. I mean, it's such a generic name, right? So, okay, so this is the IP address of our TFTP server. I don't think it will do a DNS request, so we will have to set the IP address, default BIOS file name, just like here, PXE Linux.0. And I will put it also here in the 64-bit file name for x64. You also have options for ARM. So if you want to network boot a Raspberry or something, and yeah, maybe we should enable network booting also. Okay, save. Let's restart the service just to be sure. And yeah, now it should be able to boot over the network. So let's try it out. I'm pressing escape. escape, escape, escape to get into the BIOS menu. Okay. And in here I can now select network PXE boot. That might be different on your machine. Okay, now you can see it's doing a DHCP request, and now it's downloaded the file, and here is the Debian installer that it's pulled over the network. Yeah, and that's just a regular Debian installer as you know it. Okay, so we have successfully booted the laptop over the network from a bootloader that's pulled over the network. You really shouldn't do this over an untrusted network because yeah, TFTP is not secure, and yeah, this could be man-in-the-middled and all sorts of things. And also, at least on my machine, maybe that's just a hardware thing and your machine might behave differently. But when I network boot this machine, then, well, it does a DHCP request, gets an IP address, gets a TFTP server. But yeah, if the TFTP server was in a different network, so the communication would have to go through a gateway, right? I mean, the DHCP server gives it a gateway, but it seems to ignore that. So it just, yeah, does an ARP request for the IP address of the TFTP server. And yeah, when the TFTP server is in a different network, then that ARP request will not be answered, right? So at least with this laptop here, I couldn't boot it when the TFTP server wasn't in the same VLAN. Okay, that's what I want to point out. And you might be able to get away with some trickery because in the end, if the laptop sends an ARP request, if the firewall could be configured to answer that ARP request with its own MAC address, I think this would then get the laptop to send the TFTP request to the firewall, and then the firewall would get it, see, hey, this is not for me, and forward it to the TFTP server. That might work, but I personally haven't figured out how I can configure my firewall to do that, right? So here under interfaces, virtual IPs, settings, here you can do something like proxy ARP, which sounds like it does what I want to do. But I just couldn't get this to work. So yeah, keep that in mind. Yeah, maybe with some network address translation or something, you can get this running. But yeah, as I said, running it on the same VLAN was the only way I could get this running. And so when in doubt, just put everything in the same VLAN. Okay, that's all I wanted to show you today. If you liked this video, like it, share it, subscribe, and see you next time.